Dear student, in previous video we discussed about the introduction of balancing and the definition of balancing. Now let us to discuss about balancing of rotating mass. The balancing of rotating bodies is important to avoid the vibration. Normally in heavy industrial machine such as gas turbine and electric generators, vibration can cause failure as well as noise and discomfort. This means in a gas turbine a rotating shafts are used. Okay, so whenever a certain mass is attached to a rotating shaft, it exerts some centrifugal force whose main effect is to bend the shaft and to produce the undesirable vibration in it. In order to prevent the effect of centrifugal force, another mass is attached to the opposite of the shaft at such a position so as to balance the effect of centrifugal force of the first mass. This is done in such a way that the centrifugal force of both the masses are made to be equal and opposite. The process of providing the second mass to counteract the effect of centrifugal force of the first mass is known as the balancing of rotating mass. Now let us to discuss about what is static balance. Static balance is a defined as it is a balance of force due to the action of gravity. A body is said to be in static when its center of gravity is in the axis of rotation. See, you can observe the diagram. This figure shows that a rigid rotor revolving with a constant angular velocity, that is omega, okay, in radian per second, a number of masses, that is m1, m2, m3 are the three masses revolving at radii. Those are r1, r2, r3. Okay, so these are the radii in the same plane. Then each mass produce a centrifugal force acting radially outwards from the axis of rotation. Let F be the vector sum of these force. F can be written as F equal to m1 r1 omega square plus m2 r2 omega square plus m3 r3 omega square. So in this figure we used only three masses, m1, m2 and m3. If in case one more mass we used, we can call it is m4. So F can be written as m4 r4 omega square plus so infinity, like that. So in this figure we used only three different mass and revolving at radii r1, r2, r3 respectively in the same plane. Okay, so the rotor is said to be statically balanced if the vector sum F is equal to 0, right? So if in case F is not equal to 0, the rotor is unbalanced. Then introduce a counterweight, that means balance weight of mass mc and radius rc to the balance rotor, so that we can write this equation: m1 r1 omega square plus m2 r2 omega square plus m3 r3 omega square plus mc rc omega square equal to 0. So this is the meaning of rotor is said to be statically balanced if the vector sum of F is equal to 0. Okay, so by cancelling omega square from each equation, right, we get m1 r1 plus m2 r2 plus m3 r3 plus mc rc equal to 0. So the magnitude of either mc or rc may be selected of the other can be calculated. So a summation of mr is nothing but what? Vector sum of m1 r1 m2 r2 m3 r3 m4 r4 etc. Then it can be shortly written as summation of mr, similarly plus mc rc. Okay, then the equation can be solved either mathematically or graphical method. To solve by mathematical, divided into x and z components. So summation of r cos theta plus mc rc cos theta equal to 0. Similarly, summation of mr sin theta plus mc rc sin theta c equal to 0. So we can call it as equation number 1 by arranging this kind of math equation. So this is the equation number 1 and 2. Okay, by equating equation 1 and 2 with the squaring and adding, we can be written as mr mcrc equal to square root of summation of mr cos theta square plus summation of mr sin theta square. So dividing 2 by 1, we get tan theta c equal to minus summation of mr sin theta divided by minus summation of mr cos theta. So this is about static balancing, and let us to discuss about what is dynamic balancing. So dynamic balancing is a balance due to action of inertia force. A body is said to be in dynamic balance when the resultant movement or couples which involved in the acceleration of difference movement parts is equal to 0. So we can observe there are two following condition. First one, the net dynamic force acting on the shaft is equal to 0. This condition is called as what? Static balancing. And second condition, the net couple due to dynamic force acting on the shaft is equal to 0. In other words, algebraic sum of moments at any point in the plane must be equal to 0. So these two condition 1 and 2 together gives a dynamic balancing. So let us to discuss about balancing of single rotating mass by a single mass rotating in the same plane. So you have to observe the diagram. Okay, so this here we are going to study balancing a single rotating mass by a single mass rotating in the same plane. Okay, consider a disturbing mass. So this is the disturbing mass, that is m1 attached to the shaft, okay, at angular velocity, okay, as shown in figure. Okay, you can observe the diagram. Let r1, okay, r1 be the radius of rotation of the mass m1. Then Centrifugal force exerted by the mass m1 on the shaft is given by Fc1 equal to m1 r1 omega square, right? So this is equation number 1. Okay, similarly for equation number 2, that is Fc2 equal to m2 r2 omega square, called as equation number 2. So by equating equation 1 and 2, we can calculate Fc1 equal to Fc2, right? So we know that what is the Fc1, that is m1 r1 omega square, right, equal to m2 r2 omega square. So omega get cancelled, then we have m1 r1 equal to m2 r2. So this is the equation to finding the balancing of single rotating mass by single mass rotating in the same plane. So I would like to show a simple video regarding about how the dynamic balances will be applied.
Why dynamic balancing is so important for fans. Hello everyone, my name is Fu Junzhang. More than 4 years, I've been doing dynamic balancing in Infinera. Balancing is a standard manufacturing process for each every fan from Infinera. It is actually a process of adding or removing mass in a plane or planes on an impeller to move the center of gravity towards the axis of rotation. By doing so, the fan would generate less noise and vibration during running. In Infinera, I use Schenck balancing machine, said to be the best from Germany. After boot up, the balancing machine would spin the impeller to the set speed. And the control panel will display the unbalanced position, as well as the weight to be adjusted. In most cases, I use adding weight, which is preferable. I often use bolts, nuts, and washers and place it on the blade or wheel tip for small fans. For steel centrifugal wheels, I would weld metal plates onto the wheel. After that, we will sand it for painting. If after calculation, the weight of the paint itself would influence the first run balance, I would do it again. The bolts and nuts or makeup metal panels are measured and grouped very carefully by me in advance, so that I can quickly find them. The direction of the nuts is opposite to the rotation direction of the impeller, to make sure it won't be loose or fall off during rotation. As a responsible fan manufacturer, Infinera balance each fan impeller to allowable residual unbalance prior to assembly of the unit. The unbalance level is G2.5 for small fans or G4.0 for centrifugal fans typically. G2.5 or G4.0 are defined in the technical specification of the Infinera product catalogs and are based on MCA standard 204. MCA 204 establishes allowable residual unbalance based on the balance quality grade, impeller weight, and impeller rotational speed. Why dynamic balancing is so important and so carefully maintained? Because excessive imbalance would cause vibration, and vibration generates damages and noise. Possible damages include abrasion of bearing or belts, shorter motor life, wasting power, and if it cannot be adjusted in time, the complete fan or related system might fail. I'm so skilled and experienced in balancing, but to make sure the product is reliable, I still work carefully. That is my value, and I'm proud of what I'm doing here. Thank you.
Dear student, I would like to show one more video about balancing of a single rotating mass by a single mass rotating in the same plane.
स्पीड से तो वो जो सेंट्रीफ्यूगल फोर्स क्रिएट कर रहा है आउट ऑफ द शाफ्ट वो है m1 ओमेगा स्क्वायर r1। हमें जो अब दूसरा फोर्स चाहिए होगा जिसकी वजह से हम उसे काउंटर करेंगे, उससे हमारा सेंट्रीफ्यूगल फोर्स क्रिएट होगा जो कि होगा m2 ओमेगा स्क्वायर r2। तो ये दोनों फोर्सेस बराबर हो जाएंगे। अब ये देखना जरूरी है कि ये सेम प्लेन पे लाई करते हैं, तो हमारी इक्वेशन आ जाती है m1 r1 इज इक्वल टू m2 r2। इसका मतलब ये है कि रेडियस हमारा कितनी भी दूर हो सकता है।